Hello. So if you're watching this video, maybe it's because you missed one of the properties, maybe you were absent, maybe you are working on your clue game and you're just stuck, okay? So let's go over these log properties. That way you can make sure that you have them all written in your notes, okay? So remember, the first thing that you need to remember, okay, is that, and so I want you to be thinking about this as we're doing these and as we're talking about them, okay? But I want you to be thinking about the fact that logs and exponents are inverses of each other, okay? They're inverses of each other. And so there are some exponent rules and properties that apply to logs as well because they're, again, inverses of each other. Okay, so the first log property that we're going to talk about is the log property that works for something like this. Okay, so anything to the 0 power is equal to 1, right? This is the exponent version. So that means when you go to do the log, okay, when you go to do the log of 1, no matter what the base is, that answer is going to equal 0. Because remember, with logs, they always equal the exponent. Okay, so that is property number 1. Okay, the next property has to do with the fact that anything to the first power is going to equal that thing. Okay, and so what this looks like for logs is that anything that you take the log of, no matter what it is, as long as the base is that same number, that's going to equal 1. Because again, anything to the first power equals that thing. Okay? All right, there's another exponent rule that lets you do this. Okay, x to the 6th times x squared. And if you remember your exponent rules and your exponent properties, then you know as long as the base is the same, you can add those exponents. And so this becomes x to the 8th power. Okay, so what that property looks like is that when you have a log, and I'm just going to write it a little bit bigger, but when you have a log, okay, of something like m times n, so they're being multiplied, and it doesn't matter what the base is, what you're able to do is you're able to then add those exponents together. And so what happens is you're able to pull this apart, and you end up doing the log of m with that base, and you add it to the log of n with that base. Okay, so that's what that rule looks like. So this is the idea, right? It's being multiplied. You add the exponents together. Here's something being multiplied. Remember, logs are exponents, so you pull it apart, you add those exponents, okay? The next property is what allows you to do this. So do you remember that rule of exponents where you're dividing? So if you had x to the 6th divided by x squared, you would subtract those exponents, and so that's what the next property is. Okay, so if you have the log of something, and right, you've got a base, and you're dividing, so something divided by something, okay, you're going to then subtract. You're going to subtract those exponents. So you do the log of m with that base minus the log of n with that base. Okay? The next property, by the way, we only have 2 more, but the next property is what allows you to do this, x to the 6th, and then raised to the 2nd power. So if you remember those rules and properties of exponents, this is where you multiply, right? You get 6 times 2, which is 12. And so what this one looks like is that when you're doing the log of something and it's being raised to a power, okay? And again, I just put in any old base, okay? So here's the log of something being raised to a power. What you do is you multiply. And so you end up taking this p, this power, and you pull it down in front, and then you find the log of m with the base of b. Okay? All right, the last property that you need to know is the one that allows you to change the base. So let's say you have a base of 2, and you don't want to be able to figure out 2 to the whatever power. Maybe you want to be able to type it into the calculator and use a log with a base of 10, or even a log with a base of e, which will give you the ln, okay, the natural log. So the change of base formula looks like this. It works like this. Let's say you're doing the log of something, doesn't matter what the base is, okay? You're able to change the base by doing the log of the number divided by the log of that base. And then you can put whatever base you want to put here. So you can make them both 2s if you want them to be 2s. You can make them 10s so that you can use your calculator, okay? It doesn't really matter. So I'm just going to put in an A to stand for any old base, okay? Now, what does that mean? What does that look like? And what in the world, Miss Hunsaker, are you crazy? What is this, right? So here's what we're going to be doing with them, okay? We're going to be simplifying, we're going to be expanding, we're going to be condensing, that sort of thing. I will tell you that if you see the words expand, that means that they want you to write your answer, okay, with the exponent pulled in the front, or with a minus sign between them, or with that plus sign between them, okay? If you see the word condense, that means that they want you to take the plus sign and smush it together and make it the times. They want you to take the minus sign, smush it together, and do the division. Or they want you to take this and put that p back up into the exponent, okay? So that's what the directions are going to kind of ask you. So let me show you an example really quick of how some of those work. The directions for the 3 examples that we're going to do actually say condense. Okay, so we're going to condense these logs. So the first example I want to do is this one. The log of 3 minus the log of 8. Okay? So before I do that with you, I want to show you that I promise I'm not making this up, okay? So I'm going to go type into my calculator the log of 3, and I'm going to subtract the log of 8, okay? And I get this decimal. Okay, sorry about that. So we got kicked out of there really fast. So let's go back. Okay, so what were we doing? We were doing log of 3 minus the log of 8, right? And it's this decimal. But what we can do, since this is a minus sign, okay, since it's a minus, we can condense it and we can turn it into a division problem instead, okay? We can only do that, though, because these 2 bases are both the same. Remember, if there's not a base listed, it really is a 10, right? So we can turn this into the log with a base of 10 of 3/8. Okay, so let's go type that in so that you know I'm not making this up. So the log of 3/8 is, dun, 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 the same decimal, okay? All right, next example. We have the log of 6 divided by 3. Now, for this one, so here's why I'm going to type this into the calculator, okay? So if we do this, and we did the log of 6, and then took that answer and divided by 3, okay, we get 0.259, okay? That is not the same thing as doing the log of 2. So if you just divided 6 and 3, okay, look. Those are 2 completely different decimals. Remember earlier, we got the exact same decimals because it's the exact same thing. These are not the exact same thing. Okay, so we have to be really careful about it. This particular problem can be rewritten as 1/3 times the log of 6. And since we have a 1/3 out in front, this 1/3 is kind of like an exponent. We can put it back over there. So this becomes the log of 6 to the 1/3 power. Now, if you remember from way back when, right, 1/3 can also be written as a cubed root. So there's a couple of different ways we can write this particular example, okay? All right, we have one more example to do, and then I'm going to show you the clue game, okay? All right, 4 times the log of 3 minus 4 times the log of 8. And so what we do for this one is we take the 4 and we put it up to an exponent. So this becomes the log of 3 to the 4th power. We're going to take this 4 and we're going to put it up here for an exponent. So we get minus the log of 8 to the 4th power. And again, since it's a minus, we can combine it together and turn it into a division problem. And so we get whatever 3 to the 4th is divided by 8 to the 4th. We can do the log of that. Okay? All right, let's go look at the clue game. All right, so here we are in modules, or in our home screen on Canvas. Let's go to modules or go to this week. Okay, let's go to Thursday, Feb 4 and Friday, Feb 5. And we see our little star clue. And here we go. We're going to go play clue. So when you click on the link, okay, it's going to ask you to make a copy. So go ahead and make a copy. And then what we're going to do is we're going to kind of play clue and figure out by process of elimination who found Ingrid Indigo's homework paper, where they found it, and during what class period, okay? If you go down to the bottom of the Google Sheets, down here at the bottom where it says clues, these are the problems that we're going to condense and simplify, and then you're going to find your answer on the instruction tab. Okay, so again, at the very bottom are the clues. The answers are on the instruction page. So let's go take care of numero uno. Okay, so number 1 says that we have 6 times the log of x with a base of 3, and we're adding 2 times the log of y with a base of 3. So let me show you what that looks like. Okay, so here it is. When we go to condense it, because of the plus sign, we're going to end up multiplying, okay? And we can do that because these bases are the same. Before we do that, though, we have to take the 6, and we're going to put it up as an exponent. We're going to take the 2 and put it up as an exponent. So this becomes the log of x to the 6th with a base of 3 plus the log of y squared with a base of 3. Again, since the logs are the same, we can put it together and multiply. So we have the log with a base of 3 of x to the 6th y squared. Okay? So we're going to go back into our clue game, and we're going to go look for that answer on that instruction sheet at the bottom of the Google Sheets, okay? So let's go in there, and we're looking for the log of x to the 6th y squared. Well, here it is with a base of 3. So auditorium. You're going to click on auditorium, and it's going to turn red. Her homework was not found in the auditorium. Okay, let's go do it again. Number 2. Okay. All right, so here's number 2. So we're going to do the same thing. Okay, so the 3 is going to come up and be an exponent. 7 is going to come up and be an exponent. And the minus means that we're going to divide when we're done. Okay, so we have the log of x cubed with a base of 3 minus the log of y to the 7th with a base of 3. And then we put it together and divide. So we have x cubed divided by y to the 7th. And we're finding the log of that with a base of 3. So let's go find that answer on the instruction page, and that is right here, so it's not 5th period, okay? All right, let's do one more together, and that is number 4, all right? Oh, we're going to run out of time, so go check the other video for a couple of sample problems.